Yeah. It's the law of chords. Chords just have to always be tangled. What's this? Give me a sec. No more tangled. Oh god. Oh,
Hello.
no. Yeah? Okay. Game I'm playing is Built Diff. What are you playing, dude?
Playing Bot Wars.
Oh, wait, one sec, Teacup. I can't hear you because my headphones aren't plugged in yet. Because I'm still detangling them. Loki, I should just get some wireless ones. Okay. Say something, Teacup.
I am playing Bot Wars. Bot Wars.
Bot Wars. That's dope. What's up? We got Mr. Tiger in the chat and Rip Ace. Wait, Rip Ace used to be called something else. Rip Ace, what was your old name, dude? I gotta prevent you guys from changing your names. Because I can't remember who's who.
Hold the account hostage.
Yeah, right? I thought I didn't allow people to change their names. How are they changing their names?
Well, yeah, maybe they just changed the actual name.
I think they might change their Discord account. If you change that, does it change? Is that how it works?
I think so.
Wow. Ow, why does this hurt so much? Oh, okay, there we go. Jesus. Jesu Christo, it's Friday!
That's dope.
Nah, bro.
What's up? It's Friday. I'm streaming.
One day I thought you were gonna skip today.
I was gonna skip today, because I was supposed to drive to Palm Springs for my buddy's like party thing. I was gonna do that at like 1 o'clock, and then I had to tutor a kid because he has an exam, and that ended up being 2 o'clock. And then I looked at the traffic, and it was 5 hours to go 130 miles. 5 hours to go 130 miles. I'm just like,
Just get your private
doing
jet at
that.
that point.
Yeah, right, dude. Seriously, I do need a private jet. Where's the actual jet, dude? Where's the actual education jet? Anyone got a lead on
Well,
a jet?
let's see.
Need a jet.
Well, I actually do. I actually do have a lead. It just I don't know how much your budget is.
Yeah, we gotta work on the budget. So yeah, so
what's your budget?
I looked at the traffic and I was like, no. So I figured I'll stream for you guys, and then I'll just leave afterwards later at like 8, like 7 or 8. Hopefully by nighttime it's gotten better. Let me see what. Oh, I'm not even. One sec. Let me share my screen for you guys. Oh, we're gonna stream in 4K. Yeah, hell yeah. Well, I'm only at 1440p anyways, so it's just it's the native resolution. Let me start the virtual camera. Why did this get moved up? Oh, you're Ishi. Oh, it's okay, dude. You're totally cool. Here's all I'm gonna do. I'm gonna one sec. I'm gonna change your nickname to Ripace-Ishi.
Okay, so gold. It's
Give me a
gonna cost
second,
you
I gotta
about
look
$1,000, $2,000 to get a pilot's license.
Okay. How many hours do I need?
I think you need like 60.
60. That's not that many hours. I thought you need a lot more than that. Ripace-Ishi. Okay, now I remember who you are.
No, at least 40 hours of flight time. So I was way up.
Oh, okay. Does it count if we use Microsoft Flight Simulator?
No,
That's dope.
I know
Not
it.
dope. Not dope.
So what is your budget on a plane?
What is my budget on a plane? Like, how much can we spend on the plane? I don't know. How much is a plane actually? A couple million, probably, right? A couple $1 million for a plane? No.
Depend on what plane you want. If you want like a Cessna, that's gonna run you like 40K.
Oh, that's not bad. 40K for a Cessna? No way.
No, it's only 40K.
Really?
For the 152, it's 42K.
I don't know if I would trust a Cessna for $40,000. Like, dude, you can't even buy certain cars for $40,000. What? Excuse me? How's this supposed to work? let's look up.
Well, no,
where
it's the, like,
are we gonna
1970s.
are we going to Los Angeles?
Those
Are we going to Craigslist? You want to Craigslist a plane?
Well, we will not go to Craigslist for
Let's
planes.
Craigslist a plane. What's up, Obama?
Oh,
Yeah, me and Teacup were talking about maybe buying a jet. We need a jet.
Bro,
You want a
what?
jet?
Let's buy a plane. How much for a Cessna?
Hold on. You want a plane? I mean,
These
you
are
want a jet?
okay, here we go. Here's a Cessna for 95K. It's not bad.
It's not bad.
It has a radio, it
All
looks
right, bro.
like. 1970s Cessna. Yeah? Obama, would you fly in this thing, dude? Does this thing look legit, dude?
I don't like planes.
You don't like planes?
Oh wait, really?
I don't know. What if that just crashed?
I kind of like planes.
Like, what if there's a bomber in the plane?
All right. That's the only plane they have on Craigslist. Oh, this one's 120,000. Nicer. It's
They look
nicer.
so bad. Just would
Nicer.
you actually trust those?
I don't know, dude. Dude, look at this like clock. It's look at this. Excuse me. Is this like what are these things? Oh, but it's got a mount for your cell phone though. That's nice. It's got an X mount for the cell phone.
If you got
Shifter, what's up,
$3 million,
dude?
Wow, that's
you
what you're
can
looking
afford
for?
a jet.
Yeah, dude, it's got the X mount. It's got the cell phone mount, dude. Looks like it's got some things. Yeah. That's a nice looking plane. Just doesn't come in gold. I don't know about that. Shifter says I'm leaving to
It
go to
looks pretty
Vietnam.
classical.
That's cool. I've been to Vietnam. Vietnam is sick. Where are you going in Vietnam, Shifter? What's up? Where are you going?
I'm gonna get it later. Probably.
What's up, Pav Alpha? Anybody who's in the audience, if you want to come up and speak, just raise your hand. This thing called like raise your hand, and one of the mods will get you up here.
So this plane is 70K, I think.
Okay. 170K. We're getting better. I'm getting to the more trustworthy region of things. Wait, do I have a picture of me in Vietnam? Oh, dude, this was the worst. You want to see me
Have
on
you
my?
traveled the whole world?
You want to see me on my like worst behavior, dude? This is me on my
I wanna
worst
see.
behavior. It's me at like 4 o'clock in the morning in Vietnam.
You'll probably get on my.
I should probably get on my flight.
Yeah.
Look at me, dude.
Got
These girls are
that-
trying on my glasses. I just met some random strangers. That's what I do, dude. Like, I just go to like random places. I'm like, yo, who's my friend? They have these big things called Tiger Towers, massive towers of beer. It was me riding a motorcycle. I rented a motorcycle out there. It was pretty sick.
I would fly a plane. I would not ride a motorcycle.
Motorcycles are dope. What is it? Oh,
See,
I
but
got
I
this.
don't like
I got this girl
yeah.
to write my name on her forehead.
Damn, bro, what?
Yeah, I don't know, dude. Vietnam was pretty crazy, pretty fun times. I like Vietnam. I went with my
Have you been everywhere in the world?
I haven't
at
been
this
to
point?
Africa. It's for a wedding. I'm gonna have to
been to
watch you
Denmark?
6 a.m. to Vietnamese time. That's cool. Where in Vietnam?
been
Do
to
you know?
Denmark?
Do you know? I haven't been to Denmark. Shifter, do you know where in Vietnam? Are you in North Vietnam, South Vietnam? Like this was us, for instance, on like some rickety ass boat, dude. I remember this shit, dude. This is some look at this rickety fucking boat, dude. Just this like little pontoon boat going around. Yeah. Think the South? Yeah. So probably Hanoi. Honestly, I was in Hanoi. Hanoi's fun. I'm trying to think if there's any funny pictures in here. This was the gym they had at one of the resorts we stayed in, dude. Look at it.
Bang,
The
bang,
weights
bang.
are made out of concrete. This was funny times, dude. When was
Good
this?
gym gold.
This is
That's an amazing
2015.
gym.
2015. This is very, very long time ago. Wow, it's very, very fun. Beautiful place though. Vietnam, it's gorgeous. Like it's a big, like massive jungle. Very, very, very pretty place. Nice.
Hello.
He will be playing it instead of driving? What do you mean playing it, dude? Oh, Ethan. I didn't manually ping, but when I start the stage, it does manually ping everyone. So it's okay. You don't have to do that. Sorry, my bad. I forgot about that. Okay, cool. All right. Nick's still in here. Cool. All right. Let's maybe start the stream off. Welcome everyone, Office Hours. My name is Dr. Gold. This is Actual Education, stream that helps you out with your math homework, science homework, life homework. Shifter says he's playing Job Simulator. What job are you playing, dude? What job are you simulating? Do tell. What is it? I'm curious. Yeah. Stacking shelves. That's definitely a job. That is a job of sorts. I'm not sure it's a job you want, but that is a job. Store clerk. Oh, that's cool. How does it work? Like, do you have like? This is a game on like VR, right? Isn't it? I feel like this is a game. Why is my left right all balanced? Okay, there we go. No, So now it's all right. One sec. There we go. Left, left, right, right, right. Yeah. There, 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 there. There we go. Got it fixed. Actual fight. Oh, this is cool. What's this game? What's this game you're playing? Do it for real and get paid while watching Dr. Gold, of course. Yes, thank you, Sensation, dude. Are you stacking? Are you actually stacking shelves right now? What are you stacking on the shelves? Jack's been enjoying Batman Arkham Knight. That's cool. Spider-Man. All right, let's. Probably got. Ooh, oh, we got some questions already. Where's Josh? Is Josh here? Josh, you in the chat? You are you watching? You are invalid, dude. No, chill. Da, 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 da. It is super rainy and wet here in LA. Not a fan. Weather's almost always gorgeous here, but it's definitely not gorgeous here right now.
Yo,
Dude, why does welcome not exist?
what does that even mean?
Yo, I don't know, dude. The Nightbot's like the alias you set this does not exist. Excuse me, one second. Let me fix that. What is Nightbot doing?
Well, I'm gonna go play my Batman game.
You
Y'all
go play
gotta
Bat-
learn something, cause y'all some nerds,
Do you want to
bro.
learn something, dude?
Uh,
You can always learn something. How you
Not
doing in
really.
school?
I'm
How you
like
doing in school?
smarter now.
How you doing in school?
I
Doing good?
I recently got an A- in a test.
Okay, good.
I should post that to get some coins.
You got yeah. You said you're done with Fortnite. You're not doing Fortnite anymore.
No, I ain't doing competitive. That's too
Why?
much
Because
work
there's
now.
hackers.
No, because my teammate was such a nerd.
Neat.
Like, it's like every time I play with someone else, right, competitively, we're always doing so good. But when I play with him, it's like, bro, it's like so much toxicity that you can't even stop it. I'm like,
So why don't you play with a different person who's
well, most of it is like duos, and like the season's basically over now. So there's
Oh, I see. There was some cup going on. There was some cup some people were talking about.
yeah, it was like a skin pack for some ugly kid. So I was like, nah, I ain't doing that. I don't think, yeah, I haven't even played Fortnite since I made that comment on YouTube. Like, what I've been playing recently was Minecraft, obviously. I've been playing Apex. I've been playing Batman.
Yeah. Oh, you were watching us last night playing the late night Warzone.
Yeah, I was watching it. Yeah, I was watching it like
I forgot about that.
Morning.
Yeah, Resurgence is actually
crazy?
quite fun, dude. Resurgence is fun. I have a good time with it. I have a good time with Resurgence.
I'm gonna have to get it again.
Yeah, go get it, dude. It's good.
You
Then you can
play-
play with us.
Yeah,
Fun.
you played on Wednesday,
Hey yo,
right?
bro.
And I
what
played
we
last
playing?
night. We're gonna do Roblox, but you guys can switch it up if you want. You know, depends who wants to play
I'm
what.
about to be playing Batman and stuff, so I'll see how that.
All right, cool.
Yo, Batman, it's good. He's the best game ever.
Ishi says,
Yeah.
is this the first time the weather is weird? Well, I mean, the weather's always kind of weird, but it's like especially weird. Like it's never this cold, and it's never this
Oh
wet.
yeah, that was like
Usually,
no. So there was like a cold front that happened in America, but it wasn't a cold front. Like half the places are like hot and half the places are like freezing.
I see. Sensation says he lives in the north of England. That's cool. The poor part. It really is the north part of England poor. I didn't know that. I know Scotland's up towards the north, but I don't know if Scots are. Let me see. All right, Josh has a question, but I don't see Josh yet. Where's our boy Josh? I think I tag him in the chat. And Curry Muncher's here. What's up, Curry Muncher? All right. If he doesn't want to do his, Cool. It's a chill Friday. Teacup, what's the matrix nullity, dude? What the fuck is a matrix nullity, dog?
But we've done this before. What do you mean?
No, we haven't. We've done like what the identity is. What's the matrix nullity, dude? Whatever. I'm gonna learn something with you. Everyone else is gonna learn something too. And then Ethan will do your question because I like your question. Your question has simple things. All right, today we're gonna learn what the matrix nullity is.
Welcome to Teacher Gold.
Yeah, teacher goal, dude. Sensation says historically the north was factories and mines and shipyards. Oh, okay. Where is Liverpool then? Is Liverpool in the north? Ishi's asking, is today's game, recess game, is Roblox? If it is, what game? Y'all pick. Y'all can pick which one you guys want to play.
Oh, do you want me to do a poll?
Yeah, do a poll. Make a poll. And can you make it in the poll so
question
people can suggest other things too?
That's what I had last time. I had it so you had to suggest in the chat because you can't.
I'm down to play Doors, or like I already paid for a premium server of that one thing. Like that was 300 Roblox. Like we could play that one. It's more west, I guess. Ah, yes. You know, this year was the first year I realized that Wales is a different place than England. I know like Welsh is a different language and whatnot, but like I didn't realize that they had their own like World Cup soccer team. Like, oh, that's pretty cool. Also, Italy somehow didn't make the World Cup. What? Didn't they win the World Cup like 4 years ago, 8 years ago, or whatever? Like what? What's going on there? All right, let's look up what the nullity of a matrix is. Never heard this. The difference between the order and rank of a matrix is the number of linearly independent row of column vectors if it is okay.
You're making a 10-minute poll at Steep Steps, Doors, COD Zombies by Roblox, and others. Send in chat.
Okay.
You ready to do the nullity of a matrix?
I don't know what this is, dog.
Then you better learn.
What the hell? I know there's like the rank of a matrix.
Oh, I got a 95 on my math test, but I think it's because one was keyed wrong.
Good job, dude. Good job, man. Rank? Actually, yeah, let's do the rank of a matrix. I feel like I should know the rank of a matrix. This starts getting into like slightly above my pay grade. Like I don't really teach like linear algebra so much. Okay, let's see. Okay. Rank is, this corresponds the number of independent columns of A. Rank is thus a measure of non-degenerateness. Dude, what? I love that. Non-degenerateness. I'm always a degenerate. So like what? I love this. Dude, what? This is so loaded, dude. Rank is a measure. Rank is thus a measure of the non-degenerateness of a system. Okay.
Gold degenerate confirmed.
Okay, here we go. Here, let's look at an example. This has a rank 2. The first two columns are linear independent, so the rank is at least 2. But since the third is a combination of the first two, oh, this is cool. Yeah, this one is a combination of this one. First column minus the second one. The 3 columns are linearly dependent, so the rank must be less than 3, as rank 1. Any pair of columns is generally the transpose has. Okay, you can get rank. Do you remember we were doing row reduced echelon form, right? Whatnot.
Yeah.
That's how you can get it. Okay, so row reduced echelon form takes like a matrix that looks something like this and tries to make it into a bunch of ones and like zeros, right? Remember seeing that before? You remember seeing this? You remember seeing like 1, this, right? When you get to your row reduced echelon form, the rank is the number of non-zero rows that you have. So in this case, this is a 3x3, and the only non-zero row we have here is this one. So this has a rank of 2. That's cool. Yeah, doing this by hand sucks. Like, I don't know if there's like an empirical way to do this. I think you have to do this with a calculator. So here,
we gotta do it by hand.
Let's do an example. Let's do an example question. I like this. Let me think of one. Like my health. Oh, Zara, dude. What's wrong, Zara? Are you feeling okay, Zara, dude? What's going wrong? Come on, dude. Can we go over
Bro, I had to
something
write
like
an
arc,
essay.
sine, cosine, and arc? Yes. Yes, Curry Muncher. We totally can, dude. Yeah. Oh, wait. Where'd he go? Come back. Oh, bring him back. Yes. Okay. Here, let's try to do this. Let's try to find the rank of this matrix. Pretty sure we can. Try and do it. I'm not gonna do the nullity of that. Okay.
Aw.
So this is a big matrix, okay, and we want to try to find out what the rank of it is, right? So one way to do that is to use the calculadora. Love the calculator. Calculator, my best friend.
We love the calculator. Let's put it as a matrix and do REF matrix.
Yeah, so let's do that. Let's make a matrix here. So this is gonna be a 4x4, right?
Mhm.
4x4. Let's put some numbers in. So let's do 2, 3, 4, 5, 3, 4, 5, 6, 4, 5, 6, 7, 9. Dude, this guy's funny. 10, 11, 12. Okay.
We're learning how to count.
That's cool. Yeah, I know how to count now. Okay, so now what we're gonna do is we're gonna go to matrix. Right here, second matrix. We're gonna do some math on this. I think we want to do REF. I think it's just this. I think it's just.
Well, we're just extra.
I think no. I think it's this one. I think it's just this one. Aha. Oh, do you see this?
Reduced echelon or low echelon form? Which one is it?
Well, here let's actually try doing row reduced. Row reduced. I need to look up what the difference is.
Okay.
Do row reduced echelon.
Oh, I can't do anymore.
Okay. Yeah, you're right. Okay, there we go. Cool. So what this says is if I do enough operations, enough matrix operations between like these columns, okay, like sorry, these rows and whatnot, this is like the simplest reduced form I can get. Okay, where it's like, what was that? That was like 1, 0, minus 1, minus 2, right? 0, 1, 2, 3, then 0, 0, 0, 0, 0, 0, 0. Okay, cool.
So we have 2 non-zero.
Good. We have 2 non-zero rows, right? These two rows, right? So the rank of this would be
2.
Good.
Nice.
So is that the rank of a matrix?
That's the rank of that matrix. Now, I mean,
The real question is, what's the nullity of that matrix?
I don't know the nullity yet. We'll have to look that up for next time. But if you wanted to know like how to do this using RREF, it's not that bad. Let me think here. Let me think if I can see. You want to combine the rows in different ways in order to what's up, Josh? No, you're good.
That's dope.
Good to have you back. You want to like combine these, like for instance, if I added this one to this one, do you see how if I add these, right, I would get 5, 7, 9, 11.
Mhm.
So then like I want to do something where
I'll be right back. 1 minute.
You're good. You're good. You're good. I think how could you get these ones to kill? Maybe if you double this one, let me see. 4, 6, 8, 10. No. How are they getting rid of this 12? Huh. Oh, okay. Wait. We could double this one. This one would be 6, 8, 10, 12. Okay. If I take this one and I subtract it from this one, okay, that would get me a new matrix, a new row, which would be 0, minus 1, minus 2, minus 3. Okay.
I am back, but now with T.
Glad you got some tea.
So now I can be attainable.
Then, like, you have to probably add another one to it or something. Like, then if we add this one to it, that becomes minus 1, positive 1, positive 3, 5.
So this
It's
the
like a
roses
puzzle.
that
This is
come from?
this is a massive puzzle is what it is. Which is it's cool.
Yo,
It's just,
puzzles.
Yeah, I just don't know how to do it by. I just know how to
Nah,
do
you
it with
wanna know what
calculator.
we should play? We should play Uno in Roblox.
Play Uno, dude. That'd be. All right. Here, you, Josh. Josh, are you here, dude? Does Josh have a question?
Oh, okay. I guess my question's done. Bye bye.
No, no, that counts as your question. That was a good one. I like that about the rank. Let me add one. Good. Over. Question on Monday or. Not okay. Cool. All right.
Oh, go. I'm gonna get off. Ping me when we get back.
For Roblox, I got you, bro.
Oh, just ping me if you need me for whatever reason.
Okay.
I'm gonna be playing Bot Wars Simulator, aka Murder Everything.
Yeah.
It was worth the $15. Okay, bye bye.
All right. Bye, dude. Let's see if that Curry Muncher wants to go over something. Yeah, I'll get Josh on. You're cool, dude. Just let me know. Okay. Bob's got a question though. Let's. Good. Copy that in. All right. Let's promote Bob to. Come to the stage, Bob.
Nice.
Awesome.
Hello?
Yeah, what's up, Bob? Which one do you need help with? 26?
Yeah, 26, I think. Yeah, 26.
Okay, cool. And it's rotating. Oh, what's up, Curry Muncher? You're back, dude. Curry Muncher, I'll do the next one I'll do. The next question I'll do will be yours, Curry Muncher. Is that cool? Hang around, I'll ping you for it. Cool. Sick. All right. You guys are doing Arctan? Cool. Yes, I will help you with Arctan. I'll help you with all that. That's very cool stuff. I need help. Number 2. Find the volume of the solid by rotating the reach on the. Okay, this is cool. All right, this is a good one. All right, I like this. Good one. I got you, Curry Muncher. I got you, dude. This one right here. 26. Is that what you said, Bob?
Yeah, 26.
Okay. So let's just draw all the lines we have, right? So we have y equals x, which you know is gonna look something like this, right? This is y equals x.
Mhm. Yeah.
We have y equals 0, something like that, right? We have x equals 2. Okay, so that's gonna be something like this. And then we have x equals 4. Oh, dude, this is the. Remember I was telling you, I told you to come back to me because you were gonna do this one.
Yeah.
Yeah, it's gonna happen, dude. What's up, Big Mama? Who Big Mama? Big Mama Shrey. What's up, Big Mama Shrey? All right. And then this is x equals 1. Okay, cool. And yeah, and we're rotating around this. Okay, cool. Okay. So this is gonna look yes, you can come speak. What's up, Big Mama Shrey, dude? What's up, dog? All right, so if we're rotating around here, right? This is gonna look something like this, right? But then it's also gonna like look like this. Oh, and first of all, we're going. Oh, we're doing this area right here. Oh, so I should zoom in on this. My bad. Zoom in on this. All right, we're doing. This is kind of like the disc. Do you see like the area we're doing is something like this?
Yeah.
Oh, and then it's gonna get weird. Wait. No. I'm being weird. It's this. Yes.
Hi.
Okay. What's up, dude? What's up? What's up, Big Mama Shrek?
Inflation.
Yeah, what's up? What's your question?
What are the gas prices differences, bro?
What's the difference between slope? Is that what you're asking, Shrey, dude? You're Drip Eyes, dude, right? I remember I recognize your voice, dog. I know.
Drip eyes.
Are you not Drip Ice?
No.
Oh, okay. You sound like one of the students whose name is Drip Ice. But anyways,
Well, my
look,
question is, what are the gas prices in San Francisco?
the gas prices, they're way too high, dude. Gas prices here are way too high, dude. Like, where are the gas prices where you live,
About
dude?
San Francisco.
I don't know San Francisco. I live in Los Angeles, and it's $5 a gallon here. Probably $5.20 actually. Hell
Bruh.
expensive. Yeah, bro. Bruh. I know, dude.
What's your name, doc? What's your real name, Dr. Gold?
My government name is Giovanni. Is my government name.
Hi, Giovanni.
Nice to meet you. What's your government name, Shrey?
My name is Big.
Big. Okay. That's cool. I like that. That's a good name. I'll show 'em.
All right. Can you give me something?
All right, I'm gonna move straight back to the audio. Help. Okay, Bob, do you see this right? How this is going?
Yeah.
We're gonna have to. So we're rotating around x equals 1, right?
Mhm.
Which means that. Okay. This is gonna be an integral, and then it's gonna be with regards to dy. Is what?
Okay.
Yeah. And then this is going to be pi, and then it's going to be r outer squared minus r inner squared. Have you learned that before?
Yeah.
So r outer squared will get me like this big one, and then r inner squared will get me the small one, right? Small circle. And if I subtract the two, right, then I'll get the in-between area. That make sense?
Okay. Yeah.
Okay, good. All right. Why this is a little tricky is this gets split into two regions because as I'm going up dy, right? For the first section here in this rectangle, right? My r outer will be x equals 4 and my r inner will be x equals 2. That's very simple, right?
Yeah.
Okay. But then once I get up here, now my r inner is changing as I go up, right? That's why r inner is now going to be a function of y because as y moves, I'm gonna have a different r inner that I have to do. Okay. So let's do this one first. Okay. Let's just so when we're integrating up here, let's do this part of the disk first. Where am I gonna integrate from? From y equals what to y equals what?
0 to 2.
Good. So remember, this was y was equal to x, right? So this coordinate right here is also 2, 2, right? So we're gonna do that, right? What's up, Teacup? Okay, so now the question is, what is our outer and what is our inner? Okay, that's like the hardest thing here is figuring that out. Okay, so our outer is always the distance from this outer edge to the axis of rotation. Okay, what is that distance going to be here?
3.
3. Good. So we're gonna have the integral from 0 to 2 pi, and then it's gonna be 3 squared, and then what's this distance? The inner one.
1.
1.
Nice.
Good. 1 squared, okay? And then that's going to be dy, okay? So we have figured out this area, okay? So now let's go on to the harder bit, okay? Because now we're going to do plus, and now we're going to do this part right here, this stuff, okay? So same thing, integral. This is going to be from what? 2 to where?
4.
Nice.
4. Good. Yes, because this is going to be 4, 4, right? We're going to go all the way from y equals 2 to y equals 4. Good. Okay, so that's 2 to 4, and then pi, and then what is r outer?
3.
3. Good, right? That's the distance here. This is 3 squared. What is r inner?
Is it
Tricky.
1 plus x?
Close. Remember, so here's the trick here, Bob. If I'm integrating with dy, this thing
1
needs to
plus
be in
y?
terms of, I believe it is 1 plus y. So let's see what that is. Or no, I think it's y minus 1. No. Yeah, no, it is. Okay, watch this. This is kind of cool. So I like to usually just take like an example point, okay? Let's say that x is equal to 3 here, right? And y is equal to 3, okay? Right? What should r inner be here?
Y equals X.
Well, this is y equals x, right? But yeah, that's right. But like, do you see what should this distance be? What should r inner be if we're at the 3 point?
Oh, the whole Y minus the 1.
Yes. You see how it's y minus 1, right? Because it should be 2, right?
Yeah. Uh-huh.
Okay. This is y minus 1, right? Because this right here, right, whatever the y coordinate is, that tells me the whole distance from here to here, right? But then I need it subtracted from 1, right?
Yeah.
So
Yeah.
so really what it is that, okay, so the r inner is the x distance, right, of this line. It's the x coordinate of this line, right? But the x coordinate of this line, right, is equal to y. Okay?
Okay.
And then again, I need it minus 1 because I don't need the distance from the x coordinate to the y axis. I need the distance from the x coordinate on the line to the x equals 1. So that's why it's really x coordinate minus 1, which is equal to y minus 1, all right? So here you're going to put y minus 1 squared, and then this is dy.
Okay.
You see that?
Yeah.
Does it make sense? Like, this is tricky stuff, man. This is really tricky stuff. Luckily your teacher gave you a nice one where this was just y equals x. Like, Jesus, that's so nice. Usually it's not like that. But okay. And then at this point, this is cake because you know how to integrate, right? This is pi integral 0 to 2, right? You know, of 8 dy plus pi integral from 2 to 4 of 9 dy minus pi integral of y squared minus 2y plus 1 y. Okay.
Is it possible to do it in one integral?
Yes, yeah, I could do it all in one integral if I wanted to. It's just I like to split it because this thing doesn't have any y's on it. It's just easy. Also, I mean, you could see this. This is also this is a chain rule, right? Isn't it a chain rule? Yeah.
Uh-huh.
This is the same thing as like u squared, right? du.
Yeah.
So this is the same thing as just this integrating y minus 1 squared dy is the same thing as just this is going to integrate to y minus 1 to the third all over 3.
Can I
That's what this
always
is gonna
do
be.
that?
In this case, yes, because it's easy, right? Because you see how there's nothing attached to the y. So this is a separate question, right? Let's say we're integrating y minus 1 squared dy, right? If you say u is equal to y minus 1, then du is just equal to dy, right? So this is the same thing as u squared du. This is easy, right? This gets a little tricky though. If we had something else in it, okay? So let's say, for instance, we had 5y in front of it, okay? Now u is equal to 5y minus 1, so du is equal to 5 dy, okay?
Yeah.
So then dy equals du over 5. So now this is the integral of u squared du over 5. So it's like 1/5 on the outside. So again, it's the same integral, but now you have a 1/5 out front. These are good fast tricks to know, Bob, right?
Yeah.
You remember if I'm doing the derivative of like 3x like to the 4th, that this is just 4x. Sorry, that this is just 4 times 3x to the 3rd times 3, right? It was times like the constant that's in front of it as like the chain rule. There's like an opposite chain rule for integrals where like if there's just a constant in front of it, you just end up dividing by that number. Okay. Yeah. These are cool fast tricks to know. But anyways, that makes sense there?
Yeah.
Good.
Because I was trying to do it all in one integral, so like I was like confused.
Yeah, no, break it up. Yeah. Are you talking about like you were trying to do like the rectangle and the triangle all in one?
Yeah.
Yeah, you can't do that
Like,
because
I had a weird equation. So
the issue here, Bob, is that r inner is a different function at different points. You see here, r inner is just x equals 2, but here r inner is y equals x, right?
Yeah.
That's why you have to break it up into this part, this part, and then you have to break it up in part. Yeah.
Okay.
Cool. Nice.
All right. Thank you.
You're very welcome, dude. All right, let me get Curry Muncher up here. Curry Muncher, you want to come on stage? Then Josh, I'll do your question.
Yeah, so basically we're just going over integration rules of like it's like du over square root of a squared minus u squared.
Gotcha.
And, like it's like arcsine, like you find the antiderivative and that's gonna be equal to arcsine, like arctan and arcsecant. And basically, yeah, that.
I got you. Yeah. So these are we call these like inverse trig function integrals, and like you have a bunch of tables for these technically, right? But you can actually
like,
derive these.
I
can show you how, right?
I don't get how to do the u sub and all that.
Oh, for sure, dude. I got you, dude. I got you, man. I got you. One sec. I had it somewhere. Where did I have it?
Dr. Gold,
What's up, brother?
after his question, could you go over mine?
Yes, totally, Josh. Totally, dude. Thanks for waiting, dude. You're good. So. All right. So, very much these are the inverse trig functions that you learn, right? You learn these ones?
Yeah.
Okay, good.
I get a function, but I don't get how to identify the u and the a.
Got you. Totally. Okay, here. Let me get an example question. This helps if like you have like a homework question that you already have, but I can always find one.
It's like I have a test on Tuesday for this, so.
Did your teacher give you any practice questions?
She didn't.
She
gave us a WebAssign, but.
Dude, WebAssign, dude, that's like the laziest shit ever, dude. What? Like, why don't these teachers like actually teach?
They actually teach pretty good. It's just the fact that they don't have like you don't go over a textbook or anything.
Oh, okay. Well, is it because textbooks are expensive? Like, I'm curious. What's the reason why?
It's not. It's expensive. We're a pretty rich school.
Okay.
But it's because the AP exam has like a different curriculum now.
Oh, okay. You're in AP Calc. AP Calc is what you're in?
Yeah.
Got you, bro. Okay. I know. Okay. Let's say we have this question, for example, right? Okay. And I'm asking you to find the integral of this, okay? So, usual methods of using, for instance, u substitution don't really work, right? Because this is like a massive, ugly thing on the bottom, right? So, what you want to try to do, right, is to turn this into something that looks like one of these things, okay? So, something I can notice here.
Do you take out the 2?
So, this is a trinomial. Do you see all these are binomials, which means they have 2 terms on them, right?
Yeah.
Okay. So, that means I want to try to, like, maybe factor this thing is what I want to do. Let me see. Not that one. Let me make sure this is right. What I wanted works. This is one of these things where like I have to pick numbers that are nice, otherwise it gets ugly. Okay. Cool. Okay, yeah, this one isn't too. Okay. All right. So the first thing you have to do here is you got to remember. Do you remember how to factor this?
Yeah.
Okay. How do you factor it?
So basically, you just find the denominators, not the factors of the left side and the right side with the highest degree, and then find what adds to the middle.
Good. Yeah, so what I do is I multiply these two together, so I want the factors of 8 that add up to 4. That's a little review here. I'm going to do 2 times 4 is equal to 8. There's a couple ways to do this. There's a couple ways to do this.
Is the factored form 2x plus 1 squared?
It is. Yes, it is.
Wait, no,
it is.
It's not.
Well, it's close. It's 2x plus 1 squared plus 1 is what it is.
Oh, okay.
Yeah, so this yeah, okay. So if you could see, because 2x plus 1 squared, right? That gets you the 4x squared. That's good that you can see that. You can already see that, right? You see how this is close to it?
Yeah.
It's just missing a 1? Okay, good. All right. As long as you can see that, that's cool. All right. So then this is 2x plus 1 squared plus 1. Okay? Good?
Yeah.
All right. So now I want to look at like which one does this look like? Does this look like arcsine, arctangent, or arcsecant?
It looks like arctan.
It looks like arctangent, right? Okay, cool.
Yeah.
However, there's some weird stuff going on here, right? I mean, it's pretty easy to identify what A is, right? A looks like it's just 1, right?
Yes. And then would you be 2x plus 1?
Good. U would be equal to 2x plus 1. But then here's the tricky thing, right? What would du be equal to?
2dx.
2dx. Good. So when you're substituting back into here, Curry, this is what you have to do. So you're going to rearrange this to say that dx is equal to du over 2. So this is really du over 2 over u squared plus a squared, right? So now this 2 is going to come out, right, as a 1/2. Good. And then this is easy, right? Because then this is just 1 over a. A was 1, so that's just arctangent of 2x plus 1 over 1 plus c. Okay, that's a very easy one. That's like super easy.
So first you simplify it.
Yeah. First you simplify.
The denominator first.
Mm-hmm.
And then you get a and u, and then you do the derivative of u. That gets you dx, and then use simple u sub, and then that'll get you your factor out. And
yes.
Then it's 1/2 times arctan of 2x plus 1 plus c.
Good. Yes. Yeah, it is. Okay, let me do an arcsecant one. I want to show you an arcsecant. Arcsecant is let me see. Oh, they won't. Yes, I like this one. This is a good one. Okay. All right. Let's say they want you to find the integral here. This combines a couple things, Curry, of x squared plus 6 all over x times the square root of x squared minus 4. How do we think we're going to attack this one?
So we have So first find dx of the numerator.
Sure.
I think. So
sure. Yeah.
2x dx.
Which one? So which one do we think this one looks like?
It looks like arcsecant.
Well, yeah, I did tell you I was going to do arcsecant. My bad. Yes, it looks like arcsecant. Right. Good. Yes, that's right. So so you're looking for something. So this is dx, right? But I really want to write it as du, right? But this is already looking like kind of messy and whatnot, right? Because I'm just like, wait a minute. What am I going to call my u? U is going to be what?
X squared minus 4, I think.
No. You see how this is u squared minus a squared? This has to be a squared.
Yeah.
Right? This has to be u squared. What does that mean u is equal to?
So you have dx.
So u is just equal to x, right? Do you see how that's kind of going to screw with things, though? Because if u is equal to x, then du is equal to dx. And I'm like, wait, what the shit is all this up here? Right?
Yeah.
Here's the trick. Here's the trick here.
So would you separate it?
Yes. This is like an a plus b over c situation where I'm going to separate this into a over c plus b over c. Right?
We did an example similar to this.
Good. Oh, yeah. Dude, all math is doing similar examples and, like, recognizing them later on a test. That's all math is, dude. Like, only very, very intelligent people could see this with, like, never have seen this before and know exactly how to do it. You know? It helps. This is the whole, like, you know, if you've done it once before, you'll figure it out. Okay. This, I think we should be able to do. Okay, so I'm going to break this up into x squared over something, and then I'm going to do 6 over the same thing, okay? Okay?
Yeah.
This looks nicer, right? Because how can I make this look like arcsecant?
Just get rid of the 6 in the numerator.
Just pull the 6 out, right? Good.
Yeah.
A is equal to 2. U is equal to x, right? We got our u. We got our u squared. We got our a squared. Du is dx, right? Everyone's happy. Lots of fun, right? So this whole thing here, right, is just 1 over 6 arcsecant of x over 6 plus c, okay? Easy, right?
Why would it be 1 over 6?
It's u over a. U over a. I'm fucking up, dude. No, you're so right, dude. Sorry. You're right. Sorry, it's 6, and then it was 1 over 2, so it's 3. Yes, yeah. Okay, good. No, good catch, good catch. That's what it is, okay? That's this part, right? Does that make sense?
Yeah.
Okay, what about this, though? A good one.
Would you just factor out the x, so it'd be x dx over square root of x squared minus 4?
Good, yes. So it'd be x dx over x squared minus 4, right? And I'm going to write this to the 1/2, right?
Yeah.
Okay.
Yeah.
How do you think I'm going to do this one? This is a tricky one.
Du would be equal to x.
Don't worry about du. Just worry about u is equal to.
Okay.
You'll get du later. Always try to make u equal to something is what you want to do. This is a general strategy in u substitution, especially when you're integrating things where you got stuff on the top and bottom and all mixed around and whatnot. You want to set your u to something such that the derivative of it shows up somewhere else. Okay.
Yeah. Yeah.
So what would be an idea to set u to equal to something?
X squared to the 1/2.
X squared to the 1/2 is u? Not quite, because that doesn't exist here. X squared exists, but not x squared just to the 1/2.
Yeah, x squared.
Let's try this. Let's have it be x squared minus 4. Okay. I'm gonna show you why.
So
I'm gonna make this whole
du would
thing
be
u. Good. So what is du gonna be?
Okay. 2x.
Right? dx. Don't forget the dx. Okay. Here's the reason I chose this, Curry. I know what the integral of 1 over u to the 1/2 is, right? That's an easy integral for me to do, right?
Yeah.
Okay.
Yeah.
But I don't know. Right. So if I was able to just call this whole thing u, I'd be happy. So that's why I'm going to try it. That's like the inspiration for trying it. Is like, let's try to call this whole thing u, just so it's easy. All right. And then what I want to notice is that does the derivative of that thing show up somewhere else? And it does, right? The derivative of x squared minus 4 is 2x. Bing, bing, bing. I got an x right here. It's probably going to cancel. It's kind of like a puzzle. You're looking for puzzle pieces.
Would you get set dx equal du is equal to du by 2x is equal to dx?
Good.
And then
Yeah, so let's move this,
put
right?
that in. Yeah.
Plug that in,
And
right?
then substitute that. Yeah.
I'm going to leave
That
this
would get
x
you
here.
du
Good.
1/2 du over x squared minus 4 to the 1/2. So then
Now remember that x squared minus 4 is u. So do you see how this is u to the 1/2?
Yeah.
Good. Okay. So now this goes away with this. And you'll always know you picked the right. Yeah, Bob's in calculus too. Bob says these look tough. Yeah, Bob, no, this is standard. You'll always know you picked the right u if the x's disappear. If the x's disappear, you did a good job.
Oh, yes.
If they don't, then you screwed up. All right? Or you didn't screw up. You just got to try something else. Okay, so now those go away. So now this is 1/2 integral of u to the negative 1/2 du. And you know how to integrate this, right? This is just u to the 1/2 over negative 1/2. Or sorry, over 1/2, right? Times 1/2.
Yeah. So it's
Raise the power. Oh, sorry. Yeah, good. So, but this just goes away, right? This kills off this, basically.
Yeah.
So it's negative u.
Possibly use arcsine then?
Pardon?
Or would arcsine not work?
We don't need arcsine here.
Instead?
No. We used arcsec in here. You don't need trig for this one.
Oh shit.
This is a basic integral, Curry, right? The integral of like x to the 1/2 dx. You don't need any trig for this.
Yeah.
Yeah, good.
Okay.
Yeah, so then
So
this
the
is.
u is just like a constant.
Well, no. It's not a constant. So
Not
du.
exactly a constant.
It doesn't do shit.
It's you can just take it out of the numerator.
Well,
Like,
no.
put
You
aside
always.
x multiplication.
So it's interesting. This is like it's like building a computer or something. Oh wait, why am I not? Yeah. You always need a d whatever to tell the integral what you're integrating. Okay. You always need this here, right? I can't do this integral if this isn't here. It's like I don't have a power cord attached to my computer. Like it won't work. You always need this. Okay.
Yeah.
It doesn't really do anything as long as it's just by itself like that. You just need to make sure these match up.
Okay.
Yeah. So then this is just negative u to the 1/2, and u was x squared minus 4. So that's negative x squared minus 4, right? All to the 1/2.
Yeah.
And that's what this part is,
Yeah.
right? Cool.
You just add it to.
You just add it to this part.
Yeah.
Yes. Yeah, cool. And then that's it. Then you're
Yeah.
done. That make more
It became
that make
a
more
lot
sense?
clearer now. Yeah.
Good. I'm glad.
Thank you.
Clap, clap, clap. Yeah, pretty tough, Bob. Pretty tough, but okay. Good question, Curry. Yes, you can come to the stage. Ethan, and then Josh, let's do your question, dude. You've been waiting a while. I got you, man. You here?
Thank you.
Let's do
Yeah,
it.
I'm here.
Let's do it.
Yeah.
All right.
Mhm.
Ooh, we were just talking about jets today, dude. We were talking about how I need a jet because I got to go to Palm Springs for my friend's like bachelor party something, and like the traffic is like 5 hours. It's ridiculous. Like I really don't want.
Oh,
Yes. What's up, Ethan?
Hey, when are we gonna do my question?
We're gonna do yours. Don't worry. We're gonna do it after this.
Bye, man.
Okay. On a business trip, an executive traveled 720 miles by jet aircraft, and then another 80 by helicopter. Dude, this dude's fucking rich as fuck, dude. What?
on God, bro.
On God, dude. He's got a jet and a helicopter?
You
Okay.
should donate to the poor.
He should donate to me, dude. That'd be dope.
Nice.
That would be real dope. I need this jet to go to Palm Springs. I don't want to drive in this traffic, dude. This traffic's gonna suck. All right. If the jet averaged 3 times the speed of the helicopter and the total trip took 2 hours, what was the average speed of the jet? This is a very involved question, Josh. Kind of cool.
Yeah.
Are you in physics? This is kind of a physics question almost.
I'm in algebra 2.
Okay, well,
It's not
it
my
is
head.
rates. It is rates. It's like rates, so it's kind of the same thing. Okay. All right. The key thing here. So we got to have some definitions for things. Okay. So average. Do you know what the definition for average speed is? You know how we measure average speed?
Rate over time, I think.
Close.
Or like distance over.
Total
distance
distance. Total distance
Over.
over total time.
Okay.
Okay. So however far I go in total by jet and helicopter divided by the total amount of time it took me, that's my average speed.
Yeah.
Okay. Cool.
Mhm.
All right. So we need to know the total distance and we need to know the total time. Okay. So let's have some other equations here. All right. Do you know what the distance traveled is equal to in terms of like speed and time?
Would that be speed over time?
Speed times time. Speed.
Oh.
Okay. Speed times time. Think about it this way, Josh. If you travel at a speed of 60 miles an hour and you do it for 2 hours, how far do you travel, Josh?
6 to 120 miles.
120. Yeah, good. You see how you take the speed and you multiply by the time? This will always
Yeah.
this will also come into handy when you eventually do physics with units. I hated units when I was your age. Like, is your teacher like always nagging you for units?
Yeah.
Yeah, I was like, I'm like, no, I don't want to do this. But like, units actually do make a lot of sense because like, if someone says like, I'm gonna give you 5, and you're like, 5 what? Like $5? Like 5 buckets? Like 5 what? Like units get kind of important. Speed is usually in like miles per hour, which is miles over hours. Okay, and then we multiply by a time, which is usually measured in hours. Do you see how hours over hours will cancel, like units wise?
Yeah.
And that's why you get a distance, which is in miles. So that's how you can always,
Yeah.
if you ever forget, think about the units and then multiply them. Like if you did speed over time, that would be miles over hours divided by hours, right? Which would just, that would go up top, and that would be miles over hours squared, which that's wrong. All right, cool.
Yeah.
All right, good. So I know distance is speed times time. I know average speed. So let's break this up into two. Well, so here we go. We know what the total distance is. What is the total distance based on this whole word problem?
800.
Good. Oh wow, you actually already know the answer. You don't even have to do anything here. Oh, that's too funny. What? Because what's the total time?
2 hours.
2 hours, right? Yeah. You see how this is just 800 divided by 2?
Yeah.
This is 400 miles per hour. It's that easy.
Oh.
Okay, but let me ask a follow-up question, because you see how they put all this information in here, right? 3 times the speed of the helicopter.
Yeah.
The next question they would ask, and this is why this is useful, because again, I've taught math for like so many years that I know what they ask next. The next question they would ask here, which is probably on part B, is what is the speed of the helicopter and what is the speed of the jet? That's what they want to know. All right?
Yeah.
So let's try to figure out that. Let's do the speed of the jet. And what's the speed of the helicopter? Okay. So, let's assign variables to each thing, Josh. This is usually what we do whenever we have like an algebra question like this, is that I'm going to set a variable to the things that I don't know. So what variable do you want to call speed of the jet? You can pick whatever you want.
X.
X? Okay, cool. I like X is good. What about the speed of the helicopter?
Y.
Good. Okay. What do I know about the relationship between X and Y if the jet averages 3 times the speed of the helicopter? How does X and Y relate to each other?
3x equals to y.
You said 3x equals Y?
Yeah.
Okay, everyone always makes this mistake. It's okay. Let's think about this. If the speed of the jet was 100, let's say that's X, right? What would the speed of the helicopter be?
Oh, it would be 3y is equal to x.
Good. Yes. It's okay. Dude, Josh, everyone always makes that mistake. Because it sounds like, oh, you're like 3 times it. It's like, no. This is 3 times this. You can also try plugging in numbers, right? If the helicopter's 100, the jet should be 300, right? Okay, good. X equals 3y. I like that. Okay. What's another equation that we know involving the speeds of the things and something that happens? Yeah, what do we know here?
We know that the total time was 2 hours, I think.
Good. So that's true. I don't really have the time of things yet, so that's okay.
Yeah.
Okay. Let's see. Okay, but I do know how far they traveled by jet, right? How far they traveled by jet?
No, by jet they travel 720.
Good. Okay. So do you see how here for the distance of the jet, I can write that 720 miles, right? Equals the speed of the jet, right? Which is X times the time in the jet. Let's call the time of the jet TX, and let's call the time of the helicopter TY.
Okay.
We're going to make some more variables here, right? So this is TX, okay? And then what do we know about the helicopter, which was 80 miles? How do I write that as an equation?
AT is equal to y 3y.
Good.
Wait, no, 3y times ty.
Good. It's equal to y times ty. Good. Excellent. All right. Nice. Okay. And then what do we know about tx and ty? What about these two different times, tx and ty?
Tx is the time of the jet, and ty is the time of the helicopter.
And what do those two times add up to?
2 hours.
Good. So I'm going to say that tx plus ty is equal to 2. Okay?
Yeah.
See how, okay, so we have a bunch of different equations here, right? I have this, I have this, I have this, and I have this, right? Okay. All right. I want to try to use this is why you're in algebra 2, because you're doing like systems of equations, right? Where it's like you have multiple equations and multiple things you don't know. Okay. This one's a little tricky because there's 4 things we don't know, but we do have 4 equations. So it is doable. What I'm going to try to I'm going to do a combination of like substitution and elimination is what I'm going to do to try and like make my life easier here, okay? So I'm going to substitute in, right? For here, this x, I'm going to put what I know is equal to x in terms of y. I'm going to make this equal to 3y.
Yeah.
You see how I did that? I just replaced the x with 3y. Okay. Good. So, awesome. Okay, so then the next thing I can do, right, is I can write out what this is for tx. I can write out what this is for ty, okay? So, I can say that tx is equal to 720 over 3y, and that ty is equal to 80 over y. All right? Now I can plug these into here. You see that?
Yeah.
Okay, so that's 720 over 3y plus 80 over y is equal to 2, right? Okay.
Yeah.
How do I combine these things? They got different denominators. What do I need to do?
You could multiply 80 over y times 3 to have a common denominator.
Very good. Very good, Josh. Good. All right, so that's 240 over 3y, right? Okay, so now when we add these, that's 960 over 3y is equal to 2. Which what am I gonna do? 960, is that something nice? 300, yeah, that is 960 over 3. This is 1 over 320 y is equal to 2. 960 over 3 is 320. Okay.
Yeah.
So what's the last step
Wait.
kind of here to solve for the y?
With Dr. Gold,
What's up, buddy?
shouldn't it be 320 over y because 960 is on the top?
960 is on the top, right? Oh, you are so right. Thank you for catching me on that one. Good. Thank you. You're right. Okay, good. This is better.
Yeah.
Yeah. That would have been a very fast helicopter if we did that.
Yeah.
Or very slow helicopter as well. Okay. So how do I solve for this now?
You would multiply it by y on both
Good.
sides.
Good. Yeah, I'm going to do like the butterfly method, right? So this is 320 equals 2y. 320 equals 2y. So y is equal to 160, right?
Yeah.
Okay. And remember, the units for that were miles per hour because we did everything in miles and hours. Okay. And then so if that's 160, right? Then how fast is the jet?
480.
Good. Nice, dude.
Thank you.
That was a cool question, man. I like that one. That was very involved. That was pretty dope. Did you learn something for that?
Uh-huh.
Nice, dude. Okay. Sick. Congrats to Josh. Ooh, you just got 10 bond coins. Nice. And you asked a question, so double good. Yeah, just buy the tier 1 thing in the shop and then just tell me what you want. I'll send it to you.
Okay.
Cool.
Good.
Nice. Congrats.
Thanks so much, man.
Enjoy your weekend, dude. Yeah, for sure, dude. You're welcome. All right, Ethan, what's up?
Yeah, I'm here, and I
Dude.
feel like I'm ready for this one.
You ready for this one?
I've tried to. Yeah, like I've been paying attention to the SOHCAHTOA method.
Thank you, dude. I appreciate that. Appreciate that you've been looking
So
at it.
I know exactly what you'll ask me and what I'll say.
Yeah, okay, good. I'm glad he's paying attention. He's getting ahead of it. All right, nice. Okay, airplane is flying at a height of 200 meters. Its angle of elevation. This is cool. They call this angle of elevation. All right. Calculate the distance of the airplane from the observer. Okay, how do you think you do this one, Ethan?
All right, so it says here that an airplane is flying at a height of 200 meters. Okay. All right, so right here in this diagram, it's saying like it's showing an angle of elevation.
Yeah.
And so yes, they want you to calculate the distance. Okay, so it's like you're using sine of 20 degrees or something, right?
Close. So yes, you will be. So which part of the triangle here is the distance from the airplane? Which side is it? Yeah. Do you see how they're saying calculate the distance of the airplane?
Yeah.
This is a triangle. See how this is a right triangle, right? Because this is straight down from the ground. So
this is.
We know one side of the triangle, Ethan, right? I know this side is 200, right?
Yeah. We see that.
What side of the triangle am I looking for?
Are you looking for the upper side, like the higher side?
Good. Yeah, this is called something special. Do you know what this one's called?
Is it the hypotenuse or not?
Nice.
It is the hypotenuse, dude. Good, the hypotenuse. Yeah, it's good. And this
The longest side, remember that.
is
Just
the
remember
longest
that's
side
what-
is the hypotenuse. Yeah, very good, dude. And in a 90-degree triangle, it's always going to be the one opposite of the 90-degree angle. Is what.
All right.
Good. Okay. So let's try to solve for this. How can I get the hypotenuse? You said it earlier.
All right. So I think this is when the thing before starts to come into play, the SOHCAHTOA method, right?
SOHCAHTOA. Yeah.
And I know exactly how I'll explain this.
Good. What is it?
All right. So So basically, when you see the word "so," it's like the sign of an angle for the opposite over the hypotenuse.
Very good.
The ka in SOHCAHTOA is like the cosine of an angle, which is the adjacent over the hypotenuse.
Very good. Very good.
And lastly, the TOA in SOHCAHTOA is like the tangerine. The tangerine? Is that
Tangent.
the tangerine?
Tangent.
Oh,
I
the
do like tangerines.
Okay. Well, the tangerine or the tangent of the opposite over the adjacent.
Nice, dude. I'm very proud of you, dude. Yes, you remembered those. Very good job.
Yep.
Oh, yeah.
Nice, dude. Okay. All right, how am I going to use... I need to use one of these, right, to figure out this one.
Because like the hypotenuse is on the upper one.
Good. What is this? What side is this?
This side is like the adjacent, I think.
Look at the angle. Look at the angle. Which one is... Do you see how this one is opposite of the angle?
Yeah, isn't that the adjacent?
No, this is the opposite. This is the opposite.
Oh.
Because
Okay.
it's opposite the angle that we're looking at, right? That means this one's going to be the adjacent. Which one's the opposite and adjacent? Ethan, depends on what angle you're looking at, okay? So if I was looking at this angle, then this would be the opposite and this would be the adjacent. But they give me this angle, right? So that's why this is opposite and this is adjacent.
All right.
Okay? All right, so what trick function am I going to use?
If it's the opposite over the hypotenuse, should it be the sine?
Yes.
That's dope.
What's up, Pug? Good to see you, Pug. Yes, we're going to use a sine. So I'm going to say sine of the angle, 23 degrees, is equal to what?
Is equal to 200 millimeters.
200 meters.
Oh, wait, I thought it was millimeters.
Millimeters would
And
not
then
be...
it's-
I'd be very worried if a plane was 200 millimeters off the ground. That would be bad.
How bad would that be? How
That would
bad
be
would that
that would
be? I
be
don't
two,
think
that would be 2 meters off the ground, like 6 feet.
Okay, then.
Yeah, that's not good. Don't want to jet 2 feet off the ground, 6 feet off the ground. Sorry. Okay.
All
So
right.
it's 200 meters divided by what?
200 meters divided by 1, maybe.
Divided by the hypotenuse. We don't know what the hypotenuse is, right?
Oh,
Let's remember back to the question, Ethan. We're trying to figure out what the hypotenuse is because that's the distance from the plane to the person. Right?
All right.
Go ahead. Okay, so how do I solve this now? I've sine of 23 degrees is equal to 200 over hypotenuse. Let's remember what we're trying to get to, right? I'm trying to get to this.
Yeah. So I think you have to do I think you have to put a 1 over the sine of 23 degrees.
Very good. Very good. Yeah.
Yeah, I remember that as well.
You did, dude. You're remembering things. I'm very proud of you. Okay, what's next?
All right. I think you do a cross multiply thing.
Good. We're going to do like this and then like this. So I'm going to get hypotenuse times the sine of 23 degrees is equal to 200 times 1. 200 times 1 is just 200, so we can just leave that.
Yeah.
Okay. What am I going to do next?
And then I think you use a calculator for this.
Good. So
Right.
first we got to divide both sides by something. What do we got to divide both sides by? Because I'm trying to get hypotenuse.
Sine of 23 degrees.
Good. Divide by the sine of 23 degrees. Bink, bink. Divide by the sine of 23 degrees. All right. So we get that the hypotenuse is equal to 200 over the sine of 23 degrees, right? Which, yes, this, now you need your calculator for this. So we're going to do 200 divided by the sine of 23 degrees, okay? And that's going to get us 511.9 meters. So that's how far, Ethan, you are from the airplane. 511.9 meters. Cool?
Okay. Yeah, I'm cool with this. Now
Nice,
I get
dude.
it.
That's dope.
I'm glad,
Hey,
dude.
also, could I ask you something? Could
Yeah,
I
you
ask
you
you?
can- You can ask me a question. What's up?
Could you screenshot this just so that I can remember the method?
Yeah, here I'm gonna send it to you right now. So I can always download the page. I can download the page as a
PDF.
You want a PDF? Yeah, that's fine. I can do that. I'm gonna call this Ethan. Ethan1.
Wait, hold on, wait. What do you mean by that? Like, there's different ways to download it?
Yeah, I could have done a JPEG or a PNG, but like this won't work. There you go. Here. There you go. You should be able to see that.
All right.
Yes, Minion. Don't worry. I'm getting to you, brother. I'm getting to you. And then we can give
also,
one. What's up, brother? Damn,
We actually had
67.
career
You're close to the 100. You're close to the tier 3, dude. Tier 3
Yeah,
prestige.
I'll get 70. Yeah, I'll get 70 coins once you give me those, and then
Yes.
just 30 coins away.
Yes, yeah, 30 coins, dude. I gotta announce the
Hey, wait,
prizes. I gotta announce the prizes for the vault now.
Okay, but also one thing
What's
to
up?
say.
What's up, dude?
We had career day today.
You had career day. What happened in career day?
It was literally the boring stuff. It was
Oh, no,
literally
dude.
boring.
What did they say were your careers?
There were careers like science, business, computer science, and humanities.
Okay, which one was interesting to you? None of them.
Science.
Like science? Okay, cool, dude. I'm a scientist, dude.
So yeah, I know, but then like I don't know if I could walk onto this path because it's 3 science that are major: chemistry, biology, and physics.
I teach all of them. I taught a student in chemistry before this. I have a PhD in physics, and biology is just memorizing things. So, dude, if you need help, dude, like doing well in these classes, you know, physics and chemistry and whatnot, you know, I can help you. That's why I'm here.
All right.
Yeah, you're good, dude.
I mean, I could send you my note to let you know what it's like.
Yeah, dude. If you want, if you want me to like help you like with any advice on like stuff and whatnot, like maybe what would interest you, like please, yeah, just send me a DM. I got you, man.
All right, fine. I'll leave.
All right. Enjoy the weekend, all that stuff. We'll probably play some Roblox later if you want. Otherwise, I'll see you on Monday,
Yeah.
right?
And you know, the vote on this is Doors.
Ooh, I like Doors. Doors is scary.
Because, and you know, I only beat it like 2 times.
I've only played it like
It's
twice
literally-
too, and I keep losing.
Well, I could carry the team.
Yeah, could you carry? Teacup blocked me out of one of the cabinets one time, or who did? No, or somebody blocked me out of a cabinet. I got screwed last time. Was that you, Teacup?
I'm sorry, what?
Gold, you gotta try something else, okay? You gotta hide somewhere else because
We were
you
playing
can't always
Doors,
trust me.
and I tried to hide in the cabinet.
Oh
and then
yeah, I
someone-
didn't have your cabinet.
I got griefed, bro.
I griefed you.
I got griefed. Oh my god.
And if they freaking try to grief me, that's ridiculous for them.
I know. Well, y'all can show me like other places to hide, you know. All right, let me help the last person here, and then we'll play Doors. Doors is the winning game. We'll play Doors.
Yes.
All right, now.
Nice.
What's up, Minion? What's going on, dog?
That's dope.
Damn. Someone's asking someone to draw a parallelogram at these 3 points are its vertices. Wow.
Draw those parallelograms, Gold.
Dude, it's a crazy question here, Minion. I like it. Is this a math Olympiad question from like the
Why
hardest
would
geometry
everyone
thing
getting-
again? Is that you
No, I
guys
need.
are you guys doing that to me again?
No.
No, he
Yes.
says. Dude, one of these streams, like a bunch of people kept posting like 8th grade hardest geometry math question ever, and like it took me like 30 minutes to get it, and I was like, ow, like it hurt my brain, but like it was okay. I
Yeah.
appreciated it.
That happened on like Monday or
It
Friday last
did,
week.
yeah, dude. I almost got stumped, dude. I was starting to feel dumb. I'm like, why can't I do this? And then I was like, oh, these are intentionally really fucking difficult.
Yeah, it literally took half of your stream just to figure out that one geometry question.
Oh my god, it was nuts. Okay, Sarah draws 3 points that are not on a line. She then asks Nima to draw a parallelogram that these 3 points are at its vertices. In how many ways can she choose the point? Cool. What do you know about a parallelogram, Minion? What do you know about a parallelogram?
Here's 2 parallel sides.
Good. What do we know about parallel sides? Like, what do we know about lines that are parallel? What has to be the same with them?
They will never meet.
They never meet. Good. Which means they have the same slope. That's the important thing.
Like that.
Yes, good job. We know Teacup. Very good. Okay, so let's look at here. So I have 3 points here, right? Let's just pretend that these 2 lines connect like this, right? Let's just pretend they connect like this, right? I would need this, right, to also be parallel to it, which means it would also need to connect like this. And furthermore, right, it needs to end somewhere such that this new point, right here, also makes parallel lines with each other, right?
Yeah.
You see that? So this is for sure one way that I could do it, right?
Yeah.
Now let's look what else we could do. We could also take this point, Minion. We could put it over here, right? And then we could do this. And then these would go like this. Do you see that? That's another way to do it.
Yeah.
So we at least got 2. All right, so we can get rid of the 1. All right, that's cool. All right, let's see if we can find some other ways to do it. Okay.
Try to move it down.
Yeah, let's try that. So we made we first off made this like the parallel lines that we had to do, right? Let's maybe try to do a different set. Let's say we did this set line. Yeah, okay. See how that would be different? Oh, wait, sorry. If we had if the 3 lines connect like this, right? This has to be a point, okay?
Yeah.
If the 3 lines connect like, oh Jesus, that's not a line. If the 3 lines connect like this, right? Then this has to be a point, right?
Yes.
So it's really just the different ways we can connect all the lines. Do you see how we could also connect the lines like this? And then this would have to be the point, right? So that it did that.
Right.
Right?
Yeah.
Okay.
Yeah.
So that's 3 ways at least, okay? Let me think. So we had this and this, right? We had this and this. And we had this and this. Is there another way you can connect them? I don't think so, right? Like, how else can we connect these 3 things? I think just that, then that. Yeah, there's only 3, right? Yeah, there's only 3.
Yeah.
Yeah, so I think the answer is 3. Do you know if that's correct?
Oh.
I think that's right, or is it not right?
I think it's 3.
Okay, cool. That's actually a very cool question. I like that. That was like a fun little puzzle, Minion. That was a cool one. What grade are you in, Minion?
Grade 8.
Grade 8? Okay, cool. This is pretty advanced. Is this like a geometry question, or like what?
No, like, I'm not grade 8, but like the question's from grade 8.
Oh, okay, cool. All right. Good shit, dude. Did that kind of make sense how we did that one? I liked it. It was a puzzle.
Yeah.
Okay, cool. Congrats. Good stuff, Minion.
It's like a warm-up question.
Yeah, it's like a little warm-up. Yeah, well, it's good because it forces you to remember, like, what a parallelogram looks like, and then also there's kind of like a puzzle aspect to it. I like that. That was a cool question. Good job. All right, nice. All right, that was the last question of the day. Let's wrap it up. Thank you, everyone, for coming to Office Hours.
That's dope.
Had a lot of fun learning with you guys. I had a lot of fun not being stuck in traffic. That's what I'm about to do after this. Big round of applause to our sponsors, Kathy and Kurt. Love you guys for supporting the stream this month. That's been really great. Yeah, cool. Yeah. Wow. Okay, cool. Yeah, the weekend's here. So what we're gonna do, if you guys want to play games with us, is we're gonna go to Actual Education Recess, which is where we play various games with the students. Today it's gonna be Roblox, and Teacup has done the poll for today, and we've decided that we're gonna go play Doors. So I like Doors. Doors is a fun game. So if so here we are playing Doors. So if anyone wants to come into the stream and play Doors with us, if you're still watching the Actual Education stream, it'll raid you in here real quick. Should be. Come on, girl. Let's load. There we go. Okay, cool. All right. Otherwise, have a wonderful weekend, everyone. I will be back streaming Monday at 3 p.m. Pacific time, 5 p.m. Central, 6 p.m. Eastern. We'll see you guys then. If you have any questions about math and science, you know, feel free to drop in the Discord. Join up. We do a lot of fun stuff. We give out prizes. I'll be announcing the tournament. We're gonna have a tournament coming up here pretty soon with some big prizes. I will announce that coming up soon. But anyways, I'll see you guys. If you're in the Discord, meet me in the Recess channel. I'll see you there. Otherwise, if you want to hang around and watch us play some scary games on Roblox, hang in the stream.